This is a video, a Queen Mary's College video on rusting. We'll be looking at the electrochemistry involved when iron reacts with oxygen and water. Special case of oxidations, iron obviously corrodes in the presence of oxygen and water, forming rust, iron 3 oxide, with a variable number of waters. Water of crystallization, otherwise known as hydrated iron 3 oxide. So the detail in terms of the formation of rust, the relevant electrode potentials are, and you would be given these: the iron 2 plus half cell, and the oxygen hydroxide half cell, and you can see the iron 2 plus is minus 0.44 volts, and the oxygen is plus 0.4 volts. So with the more negative electrode potential at minus 0.44 volts, we've got the iron 2 plus, and applying the anti-clockwise rule, we can see that iron is going to be oxidized to form the iron 2 plus ion. So the iron loses electrons, is oxidized to the iron 2 plus ion, releasing electrons. Those electrons are gained by the oxygen, which forms the hydroxide ion. So we've got the loss of electrons and the gain of electrons. Electrons lost and gained in this case the same. So there's our full redox reaction. We've got the iron reacting with oxygen and water, giving us iron 2 ions and hydroxide ions. Slipping in these state symbols there. You can see the aqueous products, iron 2 hydroxide. Here's the same information, starting with the more negative electrode potential of iron 2. Applying the anti-clockwise rule, iron loses electrons, so that's the oxidation process. Iron's the reducing agent in this case, releasing electrons, giving us iron 2 plus ions. And oxygen is reduced, gaining those electrons, forming hydroxide ions, since it has the more positive electrode potential. So there are the two half equations. Combined, electrons cancel, and we have our reaction between iron, oxygen and water. The products, as we said before, are aqueous, hydroxide ions, aqueous, and iron 2 plus ions, aqueous. Because iron 2 hydroxide is solid, so precipitation reaction occurs, and a complex reaction produces rust, iron 3 oxide, with a variable number of waters in the structure. So those are the half equations you need to remember, so do check those in the knowledge pack and make sure they are correctly shown. This is the same electrochemistry, except we've got a droplet of water on an iron surface, iron or steel surface. And of course the air contains oxygen, which dissolves in the water. At the center of that droplet on the iron, we've got the iron losing electrons, so the oxidation process forming iron two+ ions, which dissolves in the water. Electrons travel through the metal to the edge of the droplet. And those electrons bring about the reduction of oxygen at the edge of the droplet. And those hydroxide ions, aqueous, team up with the iron two+ ions in the droplet of water, giving us the solid iron 2 hydroxide. Further oxidation gives us rust. Adding a little bit of extra detail to the previous work, we've got iron oxidation of iron, giving us iron 2+ ions, again moving into the water. And those electrons travel from the center of that droplet through the metal to the edge, where those electrons are gained by the oxygen. So it all starts at the center of the water droplet. If you can highlight the position there. Iron's oxidized where the oxygen concentration is low, and the electrons travel through the metal to the edge of the water droplet where the oxygen reacts with its hydroxide ions. The reduction occurs where the oxygen concentration is high at the edge of the droplet. So the electrons travel from the center of the water droplet through the metal to the edge. The iron electropotential is the more negative, so that's where oxidation occurs, that's the negative terminal. And electrons travel from here to the edge of the water droplet. So that's the positive terminal. So electrons travel from the negative to the positive. So we've said already that the iron 2+ ions react with the hydroxide ions, giving us the iron 2 hydroxide precipitate, which gets further oxidized by oxygen to the rust iron, hydrated iron 3 oxide.